Top 20 Electrical Engineer Interview Questions and Answers. Prepare to ace your next electrical engineering interview with these top 20 questions and answers, covering key concepts, troubleshooting, design, safety, and industry trends every candidate should master. 1. Can you explain the difference between a relay and a circuit breaker? A relay is an electrically operated switch used primarily for control and automation purposes. It detects faults and sends signals to isolate faulty sections but does not interrupt power directly. In contrast, a circuit breaker is a protective device designed to interrupt current flow automatically in the event of an overload or short circuit. While relays are part of control systems, circuit breakers are part of power systems. Relays typically work in conjunction with breakers to detect and trip during faults. Simply put, relays detect faults, while breakers take action to protect the system. 2. How do you select the appropriate wire size for a specific load? Selecting the correct wire size involves evaluating current load, permissible voltage drop, insulation type, and environmental conditions. First, calculate the load current using Ohm's law or power formulas. Then, refer to wire gauge charts to find the wire that can handle the current safely over the required distance. Consider the derating factors due to temperature and bundling. Also, ensure that the voltage drop remains within acceptable limits, typically under 3%. Oversized wires may be safer but less cost-effective. Correct wire sizing ensures safety, energy efficiency, and compliance with national electrical codes. 3. What are the key components of an electrical power system? An electrical power system comprises three main components: generation, transmission, and distribution. The generation unit includes power stations that produce electricity using various sources like coal, hydro, or renewables. Transmission systems carry high-voltage electricity over long distances using substations and transmission lines. Finally, the distribution system reduces voltage levels for safe delivery to end users through transformers and distribution lines. Additional components include protection devices, relays, circuit breakers, control systems, SCADA, and metering systems. Together, these components ensure a continuous, stable, and safe supply of electrical power to consumers.
4. How do you calculate short circuit current? Short circuit current is calculated to determine the maximum current that can flow during a fault, helping in the selection of protective devices. Start by identifying the fault location and calculating the system impedance from the source to that point. The formula is ISC equals VZ, where ISC is short circuit current, V is system voltage, and Z is the total impedance. Use per unit or actual values depending on the system. Factors like transformer impedance, conductor impedance, and system configuration must be included. Accurate calculation is vital to prevent equipment damage and ensure safety. 5. What safety procedures do you follow when working with high-voltage equipment? Working with high-voltage equipment requires strict adherence to safety protocols. Always de-energize the equipment and verify with appropriate testing tools. Lockout, tagout procedures must be followed to prevent accidental re-energizing. Personal protective equipment, PPE, like insulating gloves, flame-resistant clothing, and face shields should be worn. Use insulated tools and maintain safe distance as per clearance regulations. Ground the equipment properly before touching. Only trained personnel should be allowed in high-voltage areas. Regular safety drills and checks ensure preparedness for emergencies. Safety is paramount to avoid fatal accidents and maintain compliance with regulations. 6. Explain the working principle of a transformer. A transformer operates on the principle of electromagnetic induction. It consists of primary and secondary windings wrapped around a magnetic core. When alternating current flows through the primary coil, it generates a varying magnetic field. This magnetic flux links with the secondary coil, inducing a voltage across it based on the turn ratio. If the secondary has more turns, the voltage is stepped up; if fewer, it is stepped down. Transformers are key in electrical systems for voltage regulation, allowing efficient power transmission and distribution while reducing losses over long distances. 7. What is the difference between AC and DC current? AC, alternating current, periodically changes direction, while DC, direct current, flows in one constant direction. AC is typically used in household and industrial power systems because it's easier to transmit over long distances with minimal losses, thanks to transformers. DC is commonly used in electronic devices, batteries, and applications requiring stable voltage. AC voltage and current are sinusoidal, making them compatible with inductive and capacitive loads. DC, being constant, is ideal for low voltage and energy storage applications. Each type has unique advantages depending on the application's requirements for stability, transmission, and efficiency. 8. Describe your experience with PLC programming. I have hands-on experience programming PLCs, programmable logic controllers, using ladder logic and function block diagrams for automation tasks. I've worked with brands like Siemens, Allen Bradley, and Mitsubishi to design control sequences for conveyor systems, motor starters, and process automation. I've configured I/O modules, developed HMI interfaces, and performed troubleshooting using software like TIA Portal and RS Logix. I'm familiar with writing and testing logic for interlocks, safety shutdowns, and alarm systems. My focus has been on optimizing cycle time, ensuring fail-safe operation, and improving machine reliability through robust control logic. 9. How do you troubleshoot a motor that is not starting? Motor troubleshooting involves systematic checks. Then check fuses, circuit breakers, and the motor starter. If these are intact, test the control circuit, such as start, stop switches and relays. Measure winding resistance and insulation using a multimeter or megger to detect open or short circuits. Inspect mechanical parts for jamming or bearing failures. Check for overheating or unusual noise. If the motor uses a VFD, examine fault codes. Proper diagnosis minimizes downtime, protects equipment, and ensures safe, reliable operation.
10. What are harmonics in electrical systems and how do you mitigate them? Harmonics are voltage or current waveforms with frequencies that are multiples of the fundamental frequency, caused by nonlinear loads like VFDs, UPS systems, and LED lighting. They distort the sinusoidal waveform, leading to overheating, increased losses, equipment malfunction, and premature aging. Harmonic distortion is measured using total harmonic distortion, THD. To mitigate harmonics, engineers use filters, passive or active, harmonic mitigating transformers, or phase shifting techniques. Also, selecting equipment with low harmonic generation and proper system grounding helps. Managing harmonics ensures system efficiency, equipment lifespan, and compliance with IEEE standards, e.g., IEEE 519. 11. Can you explain the concept of power factor and its importance? Power factor, PF, is the ratio of real power, kW, used to do work to apparent power, kVA, supplied to the circuit. A low power factor means more current is required for the same amount of useful power, resulting in increased losses and higher electricity bills. Utilities often charge penalties for poor power factor. Power factor can be improved using capacitors or synchronous condensers. Maintaining a high power factor enhances energy efficiency and reduces system load and energy costs. 12. What are the different types of electrical loads? Resistive loads, like heaters and incandescent lamps, consume power without causing phase shift between voltage and current. Inductive loads, such as motors, transformers, and ballasts, cause current to lag voltage, impacting power factor. Capacitive loads, though less common, like capacitor banks or synchronous condensers, cause current to lead voltage. Loads can also be categorized as constant or variable, balanced or unbalanced, and linear or nonlinear. Understanding load types is essential for proper system design, protection coordination, and power quality management. 13. What tools and software are you proficient in for electrical design? I am proficient in various electrical design tools and software including AutoCAD Electrical for drafting schematics and panel layouts, ETAP and SKM Power Tools for power system analysis, and MATLAB, Simulink for modeling and simulation. I also use Dialux for lighting design and EPLAN for industrial automation schematics. For PCB design, I have experience with Altium Designer and Eagle. These tools help in creating accurate designs, simulating scenarios, and verifying system performance. Proficiency in software enhances my ability to produce efficient, code-compliant, and well-documented electrical designs tailored to project. 14. How do you ensure compliance with electrical codes and standards? Compliance is ensured by following national and international standards like NEC, National Electrical Code, IEC, International Electrotechnical Commission, and IEEE guidelines. I start by thoroughly reviewing the code requirements related to my project scope. I incorporate them into design specifications, material selection, and installation procedures. I regularly consult updated codebooks, attend training, and liaise with certified inspectors when needed. Checklists and audits are used during commissioning to verify adherence. Ensuring compliance is not just about safety and legality, it builds client trust, reduces liability, and supports long-term system reliability and maintainability. 15. Describe a project where you designed or modified an electrical system. In a recent project, I designed the electrical system for a manufacturing plant extension. My role included load estimation, equipment layout, single-line diagram creation, and panel board selection. I used AutoCAD for schematics and ETAP for short circuit and load flow analysis. I selected appropriate cable sizes, breakers, and transformer ratings to ensure safe and efficient operation. During implementation, I coordinated with civil and mechanical teams, conducted site inspections, and revised designs as required. The project was completed within budget and ahead of schedule. It improved production capacity and met all safety and code requirements. 16. What is earthing and why is it important? Earthing, or grounding, is the process of connecting the non-current carrying parts of electrical equipment to the ground. It provides a low-resistance path for fault currents, protecting both equipment and personnel from electric shock. Proper earthing stabilizes voltage levels, prevents damage from lightning or static discharges, and helps trip protective devices during faults. Types include equipment earthing, system earthing, and functional earthing. Earthing is essential in industrial, residential, and utility installations for safety and regulatory compliance. It ensures fault energy is safely dissipated into the earth, minimizing the risk of fire and electric shock. 17. How do you test and commission electrical systems? Testing and commissioning ensure that electrical systems are installed correctly and operate as intended. The process includes insulation resistance testing, continuity checks, earth resistance measurements, and functional testing of protection devices. I follow standard procedures, e.g., IEC 60364, IEEE 3006, and use instruments like megometers, multimeters, and relay testers. For complex systems, I verify SCADA integration, simulate faults, and confirm proper tripping. I document test results and rectify any discrepancies before final handover. Commissioning is a crucial phase to catch issues early, validate system integrity, and ensure safety and reliability before energizing the system. 18. What challenges have you faced on site, and how did you resolve them? One major challenge I faced was unexpected cable routing conflicts during a plant upgrade. The existing underground utilities were not properly documented, risking delays in safety. I coordinated with civil teams to conduct ground-penetrating radar surveys to locate utilities. I then redesigned the routing plan and submitted it for rapid approval. To stay on schedule, we shifted non-conflicting tasks forward in the timeline. Through proactive communication, risk management, and on-the-spot engineering decisions, we avoided cost overruns and ensured a safe installation. This experience reinforced the importance of planning, adaptability, and teamwork in field operations. 19. How do you handle equipment failure during operations? When equipment fails, I follow a structured troubleshooting process. First, I isolate the equipment and ensure safety by disconnecting power. I review SCADA or control logs to identify fault codes or abnormal behavior. Visual inspections are followed by diagnostic tests using multimeters, thermal cameras, or vibration sensors, depending on the equipment type. I analyze root causes, whether mechanical, electrical, or environmental, and determine if repair or replacement is needed. I document the failure, update maintenance logs, and suggest preventive measures. Prompt, systematic response minimizes downtime, prevents recurrence, and maintains operational continuity. 20. What trends or technologies do you see shaping the future of electrical engineering? Emerging trends include the widespread adoption of renewable energy, smart grid technology, and electric vehicles, EVs, which are transforming power systems and distribution. IoT and AI integration into electrical systems enable predictive maintenance, energy optimization, and automation. The shift toward low-carbon infrastructure demands advanced power electronics and energy storage systems like lithium-ion and solid-state batteries. Additionally, digital twins and BIM, building information modeling, are improving design accuracy and operational planning. Engineers must now focus on sustainability, cybersecurity, and system resilience to stay ahead in this evolving landscape. Thank you for watching our guide on the top 20 electrical engineer interview questions and answers. Stay confident, keep learning, and showcase your skills effectively. Good luck with your interview.